Okay, hi, this is Ben Wendt. Just going to do a little crash course on Elasticsearch today, so let's get started. Okay, so I guess what's Elasticsearch? It's a search service, primarily, first and foremost. Secondly, it's a document store, so kind of like Mongo or something like that. It's a Lucene wrapper, so any kind of full text search is going to be happening through Lucene. It's a distributed database system, so that's kind of built into the architecture where you kind of are expected to have multiple servers and distributed across the network. It's kind of a schemaless database, but not really. I'll get into that a bit later. And it's fun. Yeah, so it works through kind of a REST-ish JSON API. It's not entirely RESTful, I'd say. So you do posts for making data. So like if you want to save a document, you will post to it. One thing, if you go to make a document, so like here's a fake document I have here. So this is going to be the index. Actually, before I mention that, I'm just going to say Elasticsearch doesn't have a command line like Mongo or Redis does. It just has the JSON API. So the way you generally would interact with Elasticsearch for playing around with it is using a Chrome plugin called Sense. It's made by Elastic, and it's kind of designed for this purpose. So on the left here, you have your HTTP request, and on the right is the response. So here, I wonder if I can make this bigger. Guess not. No. Oh yeah, there we go. So here we have where I'm sending the data. So this is the index here, and this is the document type. So each index is kind of like a database, and each document type is kind of like a table in the database. So here what I'm saying is to the T3 database in the H type, which isn't really very good, but that's what I put in, make a document that has bottle as one, weather is snowy, Tupperware with this date, saunas with these values, and vacation bilge pump true. So this kind of is like maybe information about a trip you're taking. But what I'm trying to describe here is you can put in integers. You can actually put in multiple kinds of numbers, strings, dates. So dates will be automatically recognized and stored as dates in the database. You can store multi-valued fields. You can store hashes, and you can store booleans. You can also store some other things like files or geodata. So when we run this, we're going to get a response. Created true, that means it worked. And here's the ID of what we just made. So I'm going to copy that because I'm going to use that in a minute. Okay, so that's basically how you create a document in Elasticsearch with a post. So when you want to get something back, it's generally through get. That's where most of the API is built around, but let's just take a look at that. So here's get. So there's different endpoints on data types. So one of the special ones is called search. If you send that query, you'll get the document you just made. So there's what we just made. There's actually, you can go here and I forget what it is, but you can go something like query equals whatever, and that will search through your documents for you. But there's generally you do things by sending a query body. So like you put a query down here. Oops. And the query would go like query whatever, or something like match. So the default is match all, and that will give me exactly what I just sent. But there's all kinds of queries that you can send through the body here. And that's kind of how you get data back out. So you can post for updates. So here's where I, oh, don't want that one. Is this it? Yeah. So say I want to update the one I just made and say there was 2 bottles instead of 1 bottle, whatever that means. So it's going to say successful, and Elasticsearch actually tracks a version number. It doesn't track the whole document, but it's going to say version 2, meaning this has been updated. And then if we go back to our other tab where we were doing the get, we'll see that the document has changed. There's that bottle 2 here. So that means that the document's updated. Okay. Next, delete for deleting data. This should all be pretty familiar to people who've done REST stuff. So here's my delete tab. So I just delete with the ID that I have on the clipboard. And go back to the get tab to confirm it. And it's gone. So that's how you delete stuff. So that's kind of like the very mile-high basics of the interface. So let's actually get into a more kind of detailed example. So I kind of made a fake shoe store here. Basically, it's a bunch of shoes. They'll have prices. They'll have sizes. They'll have a type. And they all have a brand. So I didn't make the images match the shoe other than just the brand matches, but you can use your imaginations, I guess. Oops. So yeah, I guess that's what I should say. And let's look at some types of queries we can do. So I kind of alluded to this before with the body of the GET response, or the GET request. So match all who coverage, that's the default, and it will just match everything. So match. Match is your go-to for a full text search. So this will deal with, you kind of pass in keywords and a field that you're searching against, and it will give you everything back. So let's take a look at an example of that. So if I go here, this is kind of like I'm trying to replicate the functionality of Sense, but having slightly nicer results here. So we go query match, and the field, there's kind of a magic all where it will go through all of your fields. So that's all that is. And then here's the keywords, Blundstone 7. So if we go send that request, we're going to get Blundstone. Here's a Blundstone that's a size 7, but also here's a Nike that's a size 7 because we use the all field. So that means it's going to get matches on size 7 from Nikes. So it's kind of a drawback of the all field if you're not aware of that. That's the basics of a match query. Match phrase is similar. I don't have a demo for that, but this is kind of, if you're looking through a corpus where you might have long descriptions, you might be looking for a document that matches several words near to each other, like this is my birthday cake. It makes more sense when the words are all together than when they're separated by paragraphs of text, which would be a lower score. So if you want to take kind of nearness of words into account, you'd use a match phrase. Multi-match is like match, but you can specify multiple fields. So in the other example, if we had put brand to Blundstone and size to 7, that would have been more what we were looking for. Common terms is kind of a more natural language specific thing where you don't want to just rule out all stop words altogether. So a stop word is something that is very common in text, like the, a, not, and these generally will get lots of matches through a corpus, but the documents returned aren't necessarily more relevant because the term is there. But sometimes common terms are really important, like the example here is not happy versus happy have entirely different meanings. So you might want to do a common terms query in that case. Query string exposes Lucian query string syntax directly to, so you can do things like this and that, or this. So let's take a little look at that. And that's the sheets here. So if we do query string, so the default field will be brand, so you specify a default field. And you can also, using field and then colons, specify which other fields to look in. So for this one, we should get just what we're looking for. So we're looking for Blundstone and brand, and then size 7. And then we get what we want. So that's another way to build up the queries, basically. Simple query string is a lot like query string. It supports all the same stuff, but it's meant to be exposed to end users. So the syntax is a little easier. Like instead of not, it's minus, and that kind of stuff. Okay, so another thing you can do is term. Term is going to do an exact match. So it's more like matching a field rather than a word within a field. I think I have an example of that over here. Did I do that one? Yeah. So here's term. Here we're going to be looking for things where the brand is Nike. So just brings back all Nike shoes. And terms is similar, but you can do multiple terms within a given field. So if we wanted Nike or Adidas, we could have passed in 2 things. Range is exactly what it sounds like, so let's take a look at that. There's a range query, and we want everything where the price is greater than or equal to 90 and less than or equal to 100. So that will bring back a whole different result set here, and the prices are all obviously within that range. Okay. Exists is just saying that a field exists, basically, not populated with a null value, and missing is the opposite. So you might only want documents that have a certain field. You can do regular expressions. Obviously, this is slow, but I have an example of that here. So this will actually scan through all of your fields rather than going through the index. So here we're looking for anything where the brand has an N and then anything else. So New Balance, Nike. Okay. You can do fuzzy matching. This is another scanning type query. We'll use the Levenstein distance algorithm between strings, so you can specify insertion, deletion, and replacement costs, and it will find any terms within those distances of what you're looking for. So you can also just search by type. So in like the case that I was showing before, the type was H, so you could just say, give me everything that's H. You can pass a list of IDs. And then you get into more interesting stuff like compound queries. So generally, this is done through the bool query. Bool query is like working with an AND or NOT operators, except it's more kind of aware of relevance. So a bool query, you would specify these things must be true. These things should be true. So must is like and should is like or, except instead of just being straight up, it's either true or not, it also will update the relevance factors based on what's found. And there's also a third option for a bool query called filter, which is like must, but it doesn't take into account relevance. So it's just straight up filtering whatever comes back. So store again. So this is like, say you wanted to go black shoes that are also size 9. So that's a must query, filtering by size and color. So if you look at the generated query here, this is just the backend for that output. The generated query is saying, I'll just make that a bit bigger. Here's the generated query. So you're saying, give me a filter, a bool kind of filter, where the must has color black We're looking at the wrong one. It should also say size 9 or whatever we did there. Okay, so let's go back to this guy. Elasticsearch also has geoquery capability. It's basically done by having the latitude and longitude stored as separate values in an index and then querying them both. It's pretty much the same as doing a text search. So I guess we talked about this a bit earlier where I was saying it acts like a schemaless database, but really it's not. So when you put a document into Elasticsearch, if it sees a field it hasn't seen before, it's going to guess what the value is. And then from that point forward, any document you put in that type, it's going to want to match that kind of value. So say you're putting in a field with a number. If it looks like an integer, from that point forward, it's going to be an integer. So if your first thing you put in happened to be the number 1, and then you want to put in 1.5, you're going to get an error the next time you put something in. So generally, it's better to set your mapping ahead of time. That way, the index will know what to expect. Yeah, so there's a whole API built around mapping. This is also where you, it's also where you specify any kind of analysis you want done. So you can specify what kind of tokenization you want done on your fields, whether it's indexed at all, and further analysis stuff. So mapping is kind of important, but we could probably do a whole hour just on that. So I'm not going to get into that too much. So aggregations are just for building summaries of data. So if you look at the shoe store here, these numbers I have at the top are all built from an aggregation. So we're looking at the whole result set and counting how many of each of these aggregatable fields we have. If you look here, the new and balance that's actually indicating that there was I didn't bother setting up the analysis for this field properly. So what I should have said is that it's not analyzed, and that would mean that it's not tokenized either, meaning new balance would all be one value, but I didn't do that. So let's, there's metrics aggregations. This is where you get stuff like min, max, average, percentiles. Buckets aggregations. So what I just showed you in the shoe store was a bucket aggregation. Another one, which is pretty cool, is the histogram aggregations. So you can go, give me all, so also in my shoe store, I didn't get around to filling out like a view for it, but I put in sales data. So if you look at, well, I can do it here. So here we're going to aggregate all prices with a histogram on the sold for, and then each bucket will be in groups of 5. So if we run that query, here's like an example of one of the documents. So it's basically a shoe from the other thing, plus I added a sold for with a value that's near the price and what day it was sold. And we don't really care about that here. So this will give you, when you run this query, it gives you back a bunch of buckets. The key is going to be where the field starts up until the end of the interval, and then the dot count is how many match that bucket. So that's pretty cool. You can build some nice charts with this. Better yet is the date histogram aggregation. So here we're going to go bucket by sale date on the day, and then within that we're going to bucket by prices, which is what we did on the previous one. So if we run this, we get same number of hits, but this time we get aggregations for a day. So here's the day that we're looking at, and then sub-aggregations for how many of each thing were sold that day. So here you're getting into actually being able to build more useful charts. So you could look at how many shoes were sold each day. Okay, there's also pipeline aggregations, which is what I just showed. So you can kind of aggregate on the result of another aggregation. The example they gave at Elasticon for this was going from position to velocity or vice versa, or you can do things like making multiple levels of histograms. Oh, look, that's spelling mistake. Okay. Yeah, so there's lots more you can do with Elasticsearch, but this is kind of like a primer, and could probably fill a lot more time if we got into these subjects more. So that's basically it. Does anyone have any questions?
You know, at the beginning when you did a post to put data in the database,